In this video, I'd like to talk about a type of group called cyclic groups. Now, all of the groups that we've seen before have the property that they have an infinite number of elements. So, the question is, can we have a group with only one element? Well, and the answer is yes. Just take one element, and then we define multiplication or addition, whatever you want, to be itself. I guess if I want to do addition, I should call this element 0, and maybe I would say 0 plus 0 equals 0, but whatever. We can easily define a group with only one element. We can ask the same question. I'll just use these ditto marks with two elements. And have that plural there with the S. And okay, now this question might take a little bit of thinking. If I'm going to have a group with two elements, it has to have an identity element, which I'll call 1 here. Sometimes people will use E, or if it's a group and we're thinking about it in terms of addition, we'll use 0. But for now, we're going to stick to multiplication and use 1. And I need one more element, something to go right here. And for lack of a better name, I'm going to call it X. And by the inverses axiom of a group, X must have an inverse, but by the identity axiom, X times 1 equals 1. So what is X inverse? It must be, well, X itself. So therefore, X times X equals 1. A lot of times, what we'll write instead of X times X here is we'll write, well, X squared. And of course, if you think about multiplication of real numbers, X squared is exactly the same as X times X. Here, it's exactly the same. It's just a shorthand notation. Just be careful, though. With real numbers, we can have powers that are like fractions or decimals. Here, the only things we can have are like repeated multiplication. So if I have X squared plus 1, that is the consequence of having this group here with two elements. Now we can ask about 3 elements. I'm not going to put more ditto marks on the question here, but it's actually not too hard. Well, what can we do? We start with 1, and then now we need 2 elements. But what we can do is just take X, and then this, just think about X squared. Now, if I have 3 elements, 1, X, and X squared, so where X squared is just X times X here, how can I make this into a group? Well, X must have an inverse, and that inverse has to be something that multiplies by X and is 1. Well, we can just have X squared, because, and then vice versa, if X squared, that has to have an inverse, and this inverse here can just be X. And so what we'll have is X times X squared, which we can call X cubed, is equal to 1. So our sort of defining equation, quote unquote, is the equation x cubed equals 1. And maybe I'll erase this math here, but you can do the same thing over and over again, right? If I want a group with 4 elements, I just take the group with 1 element, with 2 elements, and then sort of have, so I have a group with 1 element, meaning I have the identity. Then I take another element, and then I just sort of raise it to powers as many times as I want. And if I stick to the equation x to the 4th equals 1, then I can have a multiplication that will turn this into a group. And I can think about the axioms here. The multiplication here is associative, basically because I've defined it so that it's associative. There are always inverses. So let's look at this group that has 4 elements. What's the inverse of x squared? X squared inverse? Well, x to the 4th equals 1, so x squared times x squared equals 1. So x squared, this element is its own inverse. What about x inverse? Well, that's x times x cubed equals x to the 4th, right there. And likewise, x cubed inverse is just going to be x, right? And because I put the identity in here, this is almost a sort of formal construction. I've put the identity in here. I've defined multiplication on these elements where x sort of doesn't mean anything except for what it is. It's just x. And that makes it, and all of these things together make it a group. Okay. Now the last thing I want to talk about is another way of understanding the multiplication structure in groups. It's called a multiplication table. And the way we do a multiplication table is we sort of make a table here, and we're going to list out all of the elements. The elements maybe of this order 3 group, the group of 3 elements, I'll have 1x squared, 1x squared, and what you do is in each of the spots on this table, you put what the multiplication of those elements are. So 1 times 1 is 1. 1 times x is x. 1 times x squared is x squared. Likewise, x times 1 is x. X times x is x squared. And x times x squared, well, x cubed equals 1, so we have 1. Last but not least, 1 times x squared is x squared. X squared times x is x. And x squared times x squared, so x squared times x squared, I'll have, well, that'll be the same thing as x cubed times x, which is 1 times x, so that's just x. Oh, it looks like I wrote an x instead of a 1 here. Now, this sort of multiplication table, because the multiplication in the group, or the addition, I guess, but the multiplication in our case is something, it determines the entire group, and that's what the interesting part of a group is its multiplication. So multiplication table, which obviously isn't possible for an infinite group, but it is for a finite one. But a multiplication table can tell us kind of sort of everything about our group here. And you can try making a multiplication table for this group with 4 elements. 1x squared x cubed, 1x squared x cubed. I'll let you fill this in if you want to. It's not too hard. It's very, very similar to the other one. Maybe the last thing I'd like to say is that these groups where our defining equation is x to the n equals 1 for some n, are called, well, they're called cyclic groups. And we use the letter Cn, where n is this n right here, to denote them. So Cn is equal to 1 x dot 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 to x to the n minus 1, because x to the n is equal to 1. So for example, this group right here is C3. This one is C4. This one up here is C2. And this group with one element could be called C1. And you can have this for any number. Of course, you could have C56 if you wanted to.